Hello everyone, I'm MacSpawn, and I'm learning how to make video games. I've decided to try and make a new game every week based around a mechanic that I want to get better at designing. This week's theme was juice. You know, that stuff in games that makes you go,
Woo! Yeah, baby! That's what I've been waiting for. That's what it's all about. Woo!
when you're playing the game? That's juice. There are lots of different parts of a game that can contribute to juice. Sound effects, graphical effects, animations, etc. But the main things that I wanted to focus on were simple tweening animations, particle effects, and camera effects. Especially particle effects, which is why I called the game Particular Battles. Yes, really. One of the games I've played a lot that is a good example of this juice idea is Geometry Wars. It's also a kind of simple game to make a prototype of. It's an arcadey, top-down shooter, bullet hell type deal with simple vector-style graphics and particle effects absolutely everywhere. There's a bunch of stuff in it that I don't have time to try and replicate, like the ripple effect on the background and the variety of the enemies, but I feel like I could learn a lot by making a game that implemented just some of the same mechanics. I also wanted to take the opportunity to learn how to make some menus in Godot, so I did that as well. I'm going to go through how I made this game with a focus on the new stuff that I learned in the process. I don't know if this is the best way to do any of this, but it's a way that I did it, so it definitely works, for a broad enough definition of works. To start off with, I made a simple avatar that just moved left, right, up and down according to the player input. I did this by creating input maps for the arrow keys and then referencing them in the movement script for the player. Then, to stop the player from being able to move faster diagonally than they should, I normalized the vector. Once I had that, I needed to give the player a way to shoot. There are a bunch of different ways you could do this, probably a lot of better ways too, but the way I decided to add this feature was with a line 2D node. The first point of the line was locked in the center of the player, then the second point was controlled by the player to change which way the line was pointing. This way, I could spawn a bullet at the second point of the line, with the angle between the first point and the second. It's actually really easy to figure out what's supposed to be going on by looking at it in motion, but the difficult thing was making something that looks right in motion out of code. Because I wanted to try adding multiple control schemes, I added a boolean for mouse aim. When it's true, the player weapon will point towards wherever the mouse is at that moment. If it's false, it will point in a direction based on the WASD keys that the player is pressing down. To make it clear where the player is moving in the world, I added a particle node to it that leaves a trail of white squares wherever they go. Particle nodes generate particles with various speeds, colors, textures, and directions. You can change these properties either in code or through the UI to make them look like whatever type of effect you want. To make the trail, I made the particles shoot out in the opposite direction to the player's movement, and gave them a long lifespan so they would stick around long enough to form a path. I wanted to make the movement feel a bit weighty, but since I was using character body instead of rigid body, I couldn't rely on Godot's inbuilt mass functions. Instead, I remembered my training from my half-finished physics minor and added some acceleration to the velocity using the lerp function. Basically, when you hold down a direction, it will increase the speed of your movement in that direction by some amount every frame until you reach top speed. If you hold down no direction, you come to a stop. You can see this in action if you rapidly tap one of the directions. I found this made changing directions feel a little nicer, and made the trail of particles you leave behind look nicer too. An important part of game feel is letting the player know when they get hit. I did this in Particular Battles by adding a hit animation using the animation player node, and by adding some camera shake. The animation player node is a powerful tool. You can use it to create animations that change various properties of an object at precise timings, then call on that animation with a single line of code. In this case, the get hit animation for the player turns them red until their iframes are up, makes them jiggle a little bit using skew, and makes them rotate slightly. For the camera shake, I just straight up stole the code from this guy's video and then modified it slightly. It offsets the camera in random directions, set distance away from the center, and then that distance rapidly approaches 0 until it doesn't move at all. Watch the video in the description for a more in-depth explanation. To spawn the bullets in, I instantiated them. Basically, I loaded the bullet scene in, then adjusted a bunch of its variables like its position, rotation, and speed, and the list of groups it destroys, and then let the script run. The bullets are fairly simple. They're just collision objects with particle emitters and lights attached. They travel at a speed in a direction, both set by either the enemy or the player depending on who shot them. When they hit an object, they check the object against the list of things they can interact with. If it hits an object it can destroy, it calls the getHit function in that object, then it explodes. The explosion is just changing a bunch of properties about how the particles spawn before deleting itself. To make the explosion effect with the bullet particle node, I increased the explosiveness, initial velocity, and number of particles at the moment of impact. For some reason, even though a lot of tutorials suggest using animation nodes to control particles, I found weird visual artifacts when I used them that way. Those artifacts went away when I set the values inside the script instead. So, don't use animators to control particles because it makes the cyber spiders very hungry. I also needed some enemies to make this into a playable game, so I needed some super basic enemy AI. What I did was I created a copy of the player scene, but changed the script so the aim was controlled by code instead of by the player's mouse. I wanted to make the enemy AI take up as few resources as possible so I could theoretically have hundreds of them on screen at once. I also wanted them to be easy to dodge because it would be annoying to test the player's ability if they were too good at shooting. To accomplish this, I made them check for the player's location once per second instead of once per frame, so now, if the player is moving around a lot, they kind of drunkenly stumble in their general direction. To reduce lag spikes, I added a small random delay to when the enemy starts aiming, so the checks for the player position would be spread out over multiple frames for multiple enemies. The way I added a delay was by using a timer node. I also added one to the player to control the fire rate for their bullets, and to the bullets to stop them from flying on forever. The timer node lets you set a countdown and then sends a signal when that countdown reaches 0. For the enemy, when the timer reaches 0, it updates its memory of where the player is, and every second loop, it fires at them. To make it look a little nicer when the enemy changes direction, I used the same lerp trick as with the player motion to smooth out their turning. I also used the lerp angle method to smooth out the rotation of their weapon so it doesn't snap directly to the player. It's not exactly perfect because I still can't figure out how to make it change its speed based on how far it needs to move, so it starts turning at top speed every time, but I think it's good enough for now. I'd never done a GUI or a HUD before, either in Unity or Godot, so it took me a while to figure out exactly how to fix the UI to the screen. It was very hard to find proper info on how to do it in a form that could hold my fastidially short attention span. When I did it on my own, the UI kept sticking to the player and moving off screen like a clingy kid holding to their parent's leg at a family gathering. It turns out you need to have the canvas layer node that isn't a parent nor a child of the camera node to have it stay properly in place. Once I figured that out, I added some simple info to the top of the screen to show the number of enemies, the current wave number, the player health multiplier, and the score. Then I added a pause screen. It took me a while to figure out how to get this right, because I didn't really understand how the pause function worked. I ended up referring to this video to figure out how to do it. You can't make an object unpause itself, because if it's paused, it stops accepting inputs as well. So I needed to make the pause menu a separate object from the rest of the world. I also needed to make it so its process mode wasn't pausable, so it would work when the rest of the world was paused. Then, I just added some buttons to it that the player can click on. I wanted to make them look a little bit better than the default grey buttons, so I used this video to figure out how to make new themes for UI objects. I also added a main menu that appears whenever you start the game. It lets you change how difficult the game will be. Each wave has more enemies than the one before it, so you can control how many enemies there are in the first wave, how fast the number of enemies grows, and how many waves there are. The most important part of making a game feel good to play is making the game world respond to the player's success. An easy way of doing this in a game like Particular Battles is to reward the player for not getting hit. The way I did this was by having the player add a small amount to a multiplier whenever they hit an enemy, and have it reset to 1 whenever the player gets hit. The multiplier increases the player's max speed, the player fire rate, and the player's bullet speed, and obviously how many points they'll make for killing an enemy. This way it increases the pace of the game if you survive longer without getting hit, and it makes it feel a lot more fun. Now, this isn't perfect, but that's kind of the point. I know there are plenty of issues with the game at the moment, there are a ton of things I could do to make it better, but I'm releasing it now and stopping work on it because I've kind of reached the point of diminishing returns in terms of learning from making this game. I'm dropping it here, in the description, and abandoning it like a baby on a church doorstep so I can start on a shiny new game with a bunch of stuff I don't know how to do. I've put a link to the itch.io page where you can download the game and give it a try into the description below. Next week, I'm going to focus on enemy AI, so I'm going to try and make a simple RTS. Something that will take a lot of complicated AI coding to work properly. Something that I've literally never done before. Pray for me, guys. Anyway, until next time, take care everyone.